Hello guys, welcome back to another video. Today we're going to solve this integral, and don't worry if it looks scary at first, because I'm going to explain you step by step how to solve it in the simplest way possible. So let's jump straight into our problem. We have to solve this integral, and yes, it looks tricky, but what is the first thing we could do to make it look better? Well, we could try a u-substitution. Well, let's try. U equals log of x, so du equals the derivative of log of x dx. And now we have to find the derivative of the log of x. So if we call y equals log of x, we can use implicit differentiation to find the derivative of this function. So we know that x equals 10 to the y, and we can differentiate both sides with respect to x, and d over dx of x equals d over dx of 10 to the y. Okay, so d over dx of x is so simple, it's simply 1. And now we have to find the derivative with respect to x of 10 to the y. This is a composite function, so we can use our chain rule. So this is the derivative respect to y of 10 to the y times the derivative respect to x of our function y, that is dy over dx. Now we have 1 equals the derivative respect to y of 10 to the y. Well, what is this derivative? This is simply the natural log of 10 times 10 to the y times dy over dx. Now we can bring all of this to the other side of the equation, so dy over dx equals 1 over ln of 10 times 10 to the y. But what is 10 to the y? Well, we knew that y equals log of x, so we can simply substitute y with log of x. But 10 to the log of x is just x, so dy over dx equals 1 over x times the natural log of 10. Now we know the derivative of the log of x, so we can substitute this into our previous equation. So let's do it. So du equals 1 over x times the natural log of 10 times dx. We have to find dx, so let's bring x times the natural log of x to the other side of the equation, and we know that dx equals x ln 10 times du. Now we can finally make our substitution, so this integral equals the integral of log of x is u divided by x times u squared minus 1 times dx, that is x ln of 10 du. Now fortunately we can simplify x and x, and we can even move ln of 10 outside the integral sign because it's just a constant. So this equals the natural log of 10 times the integral of u over u squared minus 1 du. And this integral looks so better than the previous one. It seems so much simpler to solve, but we haven't finished yet. We have to solve it. And there is a simple way to solve it. And what is this way? Well, another substitution. So we have to let u squared minus 1 be equal to t. Why t? Because we used u and now we need another variable. And let's find dt. dt equals the derivative with respect to u of u squared minus 1, that is 2u, times du. So du equals dt over 2u. We can do our substitution, so this equals ln of 10 times the integral of u over t times 1 over 2u dt. we can cancel out u and u, bring the 1/2 outside the integral sign because it is a constant like the natural log of 10, and this equals ln of 10 divided by 2 times the integral of 1/t dt. And finally, we got a very simple integral, because we all know that the integral of 1/t dt is the natural log of the absolute value of t. So this equals ln of 10 over 2, the constants, times the natural log of the absolute value of t, plus the constant of the integration c, because remember we have an infinite amount of antiderivatives that depends on the constant of integration c, so don't forget the plus c. And we haven't done yet, because we have this t and we want our antiderivative as a function of x, because we were integrating respect to x. So what can we do about it? Well, remember that t equals u squared minus 1, so let's do the substitution. So this equals ln of 10 over 2 times the natural log of t, that is u squared minus 1, plus the constant of integration c. We haven't finished yet because we still have that u, so we can do another substitution. In fact, remember that u equals the log of x. So let's do the substitution, and we get that this equals natural log of 10 divided by 2 times the natural log of the absolute value of log squared of x minus 1 plus the constant of integration c. And this is finally our final answer, because this is the antiderivative we found. And how crazy was it? 2 simple substitutions, and we got from this crazy integral to a simple, well, not so simple antiderivatives, but at least we got here in 2 simple steps. How crazy are integrals? You can solve it in a matter of seconds, or they can be so difficult you cannot find them easily. So this is what makes integrals specials respect to derivatives, that, well, for derivatives you just apply the rule over and over again. We have the sum rule, the product rule, and so on. But with the integrals, you have to find a solution, a way to solve your integral, and this is so nice, and it's also so satisfying when you get a result. So let me know in the comments if you would like to see other video about integrals. Don't forget to subscribe to my channel, leave a thumbs up and share this video with your friends. And as always, until next time, bye!